This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video we will be looking at interest under the Financial Math section. So here we see some basic formula that will be given in the log tables and exams to do with financial maths. So we have compound interest, we have present value, and we have depreciation. In the equations above, we see that I is equal to interest. So this is written as a decimal and not as a percentage. In the question, it will be given in the form of percentage. You will need to convert it from percentage into a decimal. And the previous video in this series is devoted to that kind of thing. P is equal to the principal value, also known as the initial value, or the money maybe you have now, or maybe the money you would need now if you wanted to have a certain amount of money in the future. F is equal to the final value, and T is equal to time. So we can see these formulae are all quite similar. You see that compound interest and depreciation are very similar in particular, the only difference being the positive and negative signs in the right hand side of both. So in compound interest we have a positive sign. This speaks compound interest over time. We are gaining money, meaning we are adding. In depreciation we are losing money, so we have a negative. Present value then is rearranging the compound interest formula to solve it for P. So we'll look at compound interest first. So this is used to find the future value of a sum of money that's been put in a bank with a given interest rate over a certain time. So if we look at an example, you see Andy has put €4,000 in the bank for 3 years at an annual rate of 5%. How much money has he got at the end of the 3 years? So first off, how would we know which formula to use? Well, we can see by the question, we know we're looking for a future value. How much money has he at the end of 3 years? So that means we're either dealing with compound interest or we're dealing with depreciation, as both of these follow the F is equal to future value. So which one do we pick? Well, we see that the money is put in the bank for 3 years at an annual rate of 5%. So this means he's gaining interest on the money, which means we need to use the compound interest formula. And once we know that, all we need to do is identify in our question what P, I, and T are. So P is 4,000, T is 3 years, and I is 5%, or in decimal form, 0.05. So F equal to P times 1 plus I to the power of T gives us 4,000 times 1.05 to the power of 3, which is 4,630. So if we look at the present value next, as mentioned before, if we rearrange the compound interest formula to isolate P, we end up with the present value formula. So how this is used is, if we look at an example, Mary wants to have €4,800 in the bank after 4 years. How much money will she need to deposit now if the annual interest rate is 6%? Again, we know to use the present value formula based purely on the fact that how much money will she need to deposit now? We need to know how much money she wants now, i.e. at present. So once we know we're using this formula, again we need to know in our question what F, I, and T are. For us, Mary wants to have €4,800 in the bank after 4 years. The future value she wants to have in the future, is 4,800. We know that T is 4 years, and again the annual interest rate is 6%, or converted to decimals is 0.06. So now that we know this, we can throw all of these things into the formula. So we get that P is equal to F all over 1 plus I to the power of T, which is equal to 4,800 all over 1.06 to the power of 4, which is equal to 3,000 €4,802.05. So that's the amount of money she needs to put in the bank now to have €4,800 after 4 years. So lastly, we'll look at the depreciation formula. It's used in the same way, except in situations where we're dealing with something that loses value over time. So we're looking at an example. A house depreciates by 1% every year. So the value of the house decreases by 1% every year. Gary bought this house for €350,000 in January 2008. What is its value in January 2020? So, again, how do we know which formula to use? Well, as we can see, the word depreciates is in the question. So initially, we're going to think we need to use the depreciation formula, which is correct. So P is the original value of the house. So the present value in 2008, which is €350,000. T is the number of years which will pass between 2008 and 2020, which is 12. And we can see that it depreciates by 1%, which gives us that I is equal to 0.0. So, throwing all of these things into our formula, we see that F is equal to P times 1 minus I to the power of T, which is equal to 350,000 P times 0.99 all to the power of 12, giving us €310,234.71 as the value of the house in January of 2020.